my title actually I revised my title to hydroelectric interplay at the liquid-solid interface. And my presentation includes 4 parts: background and the conversion from water kinetic energy to electric energy, and the reverse process, the electric the conversion from the electric energy to water kinetic energy, and the summary. Let's start with 2 common phenomena in science. In the left side, when we close electrically charged object to the water flow, and the water flow will deflect to the object. In this video is the Teflon rod. This such a process gives a demonstration of the conversion from the electric energy to water kinetic energy. And the right side give a technical Kelvin water dropper. It utilizes the water flow to generate electric output with the voltage output reaching thousands of watts. Such a process gives a demonstration of the conversion from the water kinetic energy to electric energy. So how this conversion between the water kinetic energy and the electric energy occur? We can get the answer from the molecular structure of the water. The water is composed of 2 hydrogen atoms and oxygen atom, and the center of the 2 hydrogen atoms does not locate on the position of the oxygen atom, which means that the water molecules are polar molecules, and the polarity of the water is far larger than the other liquid. So the water can have a stronger interaction with the electric field. And such an interaction between the water and the electricity can be further amplified in the liquid-solid interface. This is because there is an electric double layer formed at the liquid-solid interface. So effectively regulating the hydroelectric interplay is promising to promote the mass and momentum and energy transfer at the solid-liquid gas interface, which has many applications such as this. And let's forward to the second part, the conversion from the water kinetic energy to electric energy. That is the water energy harvesting. The current techniques can harvest water energy from the water evaporation, osmosis, and even the humidity gradients. However, these techniques harvest the water energy from the interfacial effects between the water and the materials. Therefore, these techniques will lead to a low power density and a low energy conversion efficiency. So my work is to solve this efficiency problem to achieve high efficiency water energy harvesting. Our method is leveraged on the ancient triboelectric effects, which have been discovered for 2,000 years. And when we brought 2 objects into contact and separate, positive and negative charge can generate on the 2 objects respectively. Such an effect is also applies between the water and the solid. In some special solid materials such as Teflon can accumulate sufficient surface charge with the continuous contact with water. In this video is dropped. And such a triboelectric effect can be used to electricity generation to generate electricity. In the conventional design, an electrode was fabricated on the bottom of the Teflon, and the device can generate electricity from the droplet, from the generated triple electric charge when the droplet impacts on the surface. But however, we can see in the video the indicator of the electricity generation, the LED bubbles cannot be lit up. This is because the conventional design uses the triple electric belts, which is very limited, and although the solid surface stored with sufficient charge, but this charge cannot be fully used. So now the question is how to utilize this surface charge. Such a similar problem arose in a semiconductor field 60 years ago. The invention of the transistor gives the invention of the transistor gives a solution. The transistor is composed of a source and a drain and a gate. Inspired by this, we designed a transistor-like generator that can be used to harvest the water energy. We conduct the surface electrode on the Teflon surface. The Teflon stored with sufficient charge, and the bottom electrode can be treated as a source, and the surface electrode can be treated as a drain. The droplets that can bridge the source and the drain can be treated as a gate, just like that in the transistor. With such a design, we found that the power density and the energy conversion efficiency can be improved by thousands of times. And as we can see in the video, when the droplets impact on the solid surface, the LEDs, over 100 LEDs can be lit up. When the droplet impacts on the surface, as we can see in the video, the droplet is switch of the electricity generation, controlling the charge transfer between the bottom electrode and the drain electrode. Such electricity generation process can be also explained as by the electric circuit model. The Teflon can be treated as a capacitor C1, and when the droplet is spread and spread on the Teflon surface, the water PTFE surface can be treated as another capacitor C2. However, before the droplet contact with the drain electrode, these two capacitors are in open circuit state. There is no charge transfer in the circuit. When the droplet contact with the drain electrode, another capacitor C3 formed as the water and the electrode interface. The whole circuit is closed, and the charge stored in the capacitor C1 can fully released to C2 instantaneously, and resulting in a very high output. And such a design can harvest not only the small scale water energy, but also can harvest the large scale water energy by using the PCB technology. The design can also be used to harvest the water energy in various environments. For example, we can encapsulate a droplet in a closed channel and utilize the droplet in the channel to generate electricity. And with such a design, we can also harvest the bubble energy in underwater environments. As we can see in the video, the droplet dynamic actually regulates the charge transfer between the electrodes. The bubble energy generator can also be used to serve as the power supply of some electronics, such as hydro thermography, and it demonstrates its potential in offshore wireless power generation, eliminating the long distance wiring and the energy transportation. This design can also be used to harvest the water energy various interfaces, including solid gas interfaces and liquid interfaces and liquid solid interfaces. Now, after we resolve the efficiency problem of the water energy harvesting, we also propose a method to enhance its durability. In practical application, the solid surface is easily polluted by the marine organism. We want to propose surface materials that can be anti-fouling, anti-icing, and rapid reduction. The natural pitch plant gives us a solution for this. Its surface has a stable lubricated layer that can be used to catch insects. Inspired by this, we designed a surface, liquid infused surface that sleeps as the generator. Compared to the hydrophobic surface or pseudo-hydrophobic, the sleeps has a more stable droplet motion and thereby leading to a more stable electric output. And moreover, we also demonstrate that the sleep-based device can achieve a stable electric generation on the various environments, including the low temperature, the high humidity, and in the salt solution. Moving from the conversion from the electric energy to water connected energy, we continue studying the conversion from the electric energy to water connected energy, and the electrically controlled the droplet motion has many advantages, such as non-contact, non-diffuse, and high responsiveness and high precision. The electrowetting based method has received great success, but it also has many problems, such as difficult preparation, complicated control circuits, and the requirements of the size matching between the droplet and the electrodes. To resolve this problem, we propose a triple electrowetting method to achieve droplet motion control. The key of our design is a molecular layer that can store electrostatic charges that from the contact between other objects. As we can see in the picture, this layer can store with sufficient electrostatic charge. So we can call this layer as virtual electrode. And when this virtual electrode is charged, the droplet shows a similar weighting effect just the same as that in the electrowetting. Different from the utilization of the electric input to control the droplet motion, we use a special mechanical electrode to control the droplet motion. When there is electric motion between the virtual electrode and the mechanical electrode, electrostatic charge generated on the virtual electrode and the potential difference generated between the virtual electrode and the mechanical electrode, and generates and produce a driving force acting on the droplet. With such a triple electric effects, we can, as we can see in the video, the droplet can be transported on the flat surface and on the vertically spaced surface, and even on the 3D flexible surface without any additional inputs. This is the surface electrical tension generated by the potential difference. And as we can see the picture, the surface electrical tension in the advancing edge of the droplet is far larger than the receiving edge, which is consistent with the droplet's motion direction. Integrating the surface electrical tension can give a overall driving force acting on the droplet. As you can see in the figure, with the actuation of the electrodes, the driving force acting on the droplet can increase and can overcome the excitation force acting on the droplet and actuate the droplet motion. With such a triple electric vacuum effects, we can achieve a series of applications, including the chemical reaction on an open surface or in a closed channel, and the surface of focus removing. In addition to the triple electric vacuum effect, we also proposed electrostatic remote control of the droplets. We applied a high voltage on the electrode that is closer to the droplet placed on a superhydrophobic surface. The opposite polarity charge can be inducted in the droplet, and the attraction force can be formed between the droplet and the electrode. With the electrode array, we can achieve a long distance droplet transportation, including in the trapping mode and in the continuous trapping mode. In summary, my work focuses on the hydroelectric interplay as a liquid-solid interface, and to achieve the high efficient conversion between the water connector and the electric energy. In the next step, our work will surrounding the mechanical innovation, theoretical analysis, device fabrication, and multiple applications.